Now, when we get to looking at a more complicated curve, like this inverted parabola, we don't have the tools readily at hand to be able to just find out the area. So what we're going to do is instead look at an approximation. And we're going to approximate this area using some easy areas to find. And we're going to use rectangles. And so what I'm going to do here is we're going to construct some rectangles here and work out those areas and approximate the area of the whole thing. Now, I've got a couple of choices here. I could have a rectangle where I fix my height by when it first hits the curve. So I've got one rectangle there, another rectangle here. The third one's going to hit it immediately, so it's like a almost non-existent or a non-existent rectangle there. And then approximate this area by those. And here I've fixed it so that the left-hand side hits. And my other option is I could have done a rectangle that's slightly bigger and done it where it last hits it, or the final one, so that would be that one there, and this rectangle would go up to here. And we can see in both of these cases, so for the orange one, I'm underestimating by these bits, and the yellow one, I'm overestimating by these bits. It's not going to be perfect, but it's going to give us an approximation. So how would we do that? Well, if I label these A and B, and we don't really have to worry about C, so the area of A, well, that's a rectangle, so it's length times width. This width is going to be 1, and the length is just the height of this, and it's a height at that x equals 2. So if I go back to my function at x equals 1, when I look at that x equals 1, 1 minus 1 squared minus 1 plus 9 is 8. So that's going to be 8. And my area of B is going to be similar. Again, it's going to be a width of 1, but here it's looking, the height's going to be according to where x is 2. So 2 squared is 4, minus 4 plus 9 is 5. So I got 5. And this one's got a height of 0. So that's going to be 0 times 1. It's going to be 0. So my orange area would be 13. Now, I can do similar with my yellow area. So I got A, B, and my C this time. So my A is going to be times 1. This time I'm looking at this left-hand side. So x equals 0. I've got 0 squared is 0 plus 9 is going to be 9. My B is going to be, this time looking here, that's when my x is 1. That's the one I just did there. We know that's 8. And C is going to be at my left-hand side of this one again, but this is the same as my B from before. So that's 5. So my total here equals 22. Now we can see that these are radically different numbers. So which one's correct? Well, neither of them are. It's going to be somewhere in between. How could we get it better? Well, there's a number of ways, and we're going to talk about that in the future. We could reduce the size of these rectangles. I could make them half as big, and then I'm going to get better estimates. I could make them 1/10 as wide, and I'll get even better. So that's one way we could do it. We could use a different rule. Instead of looking at rectangles here, we could look at trapeziums. So slanting slopes down here, and that would get us a much better result. We could stick with rectangles, and instead of going from the left or the right, we could do it the middle point. And that would, at least in this case, give us better ones. And there's some other rules that we could use.